Hello everyone, my name is Sadia and our topic for today is atomic radius. So we are starting by giving a very short definition about the atomic radius. Basically, atomic radius is defined as the average distance between the nucleus of an atom and the outermost orbit is called atomic radius. So firstly we have to understand what is basically nucleus. This is the nucleus and here we have proton and neutrons, okay, and this is called the orbit, okay. If electron is present here, so basically this is the distance, this distance would be called as atomic radius, okay. Moving forward, like we have two atoms, okay. Suppose this is an atom of hydrogen and this is bonded by a covalent bond, single covalent bond, and basically the distance between these two nucleus, an average of this, like distance of H2 molecules, nuclear distance between the H2 molecules divided by 2 is the radius of one hydrogen atom, okay. Why is it so? Why we are not finding atomic radius in free state? Because like because the size of an atom is always defined. You know that size of an atom is always defined by the edge of its orbital. However, the orbital's boundaries are fuzzy, and in fact they are variable under different conditions. Like we have cation, if we have cation, like we have sodium and sodium ion, sodium cation. The sodium will have the greater size compared to cation because we have removed one electron. But in case of, if we are taking an example of chlorine and chlorine minus, the Cl minus will have the larger size because we have added one more electron, so its boundary will automatically increase. That's why we always find out the atomic radius in bonded state, okay. So what would be the proper definition for this atomic radius? Basically the atomic radius is defined as the half of the distance between the nuclei of identical, you can say non-identical as well, it is not necessary, we don't have identical atoms in every case, we have non-identical atoms too. Identical atoms are bonded together, so half of the distance between the nuclei of identical or non-identical atoms that are bonded together, okay. Moving forward, like we have I have given here an example. Like I have given the radius internuclear distance of H2 molecule 72 picometer, and I have asked the radius of hydrogen atom. So what would be the how we will find out? Like we know that half of the distance between the internuclear distance of a molecule bonded by single atom is the atomic radius. So this is the 37 picometer is the atomic radius of radius of hydrogen, okay. Now moving forward, like now we will talk about the trend. This is our periodic table. So we have seen, if we move from left to right, if we are moving from here to here in a period, we have seen the atomic radius decreases, okay. But if we move from here to here, from top to bottom, we have seen atomic radius increases, okay. Like we have sodium and potassium, which will have greater radius. The potassium will have greater radius. But if we have oxygen and fluorine, which will have greater radius, oxygen will have larger radius, okay. We will moving forward, I will give you the explanation for this trend, okay. Firstly we will talk about the trends across the periods. Like we have, okay, in the group, we know that atomic radius of elements increase with the increase in atomic number from top to bottom. We know that when we move from top to bottom, the atomic number keep on increasing, okay. As we move down the group, the number of shell increases. Also, if we are increasing the atomic number, we have to increase the electrons are also increasing. For the accommodation of that electrons, we have to include we have to add more shell, okay. So when we move from top to bottom, we have more number of shells, orbit, you can say orbit, okay. So the valence electron lies farther and farther away from the nucleus, because we know that for atomic radius to find out, we know that the distance between, like here is an atom, and the distance between the outermost valence shell and the nucleus is the atomic radius. So when we move down the group, the valence electron lies farther and farther from the nucleus, and that's why the attraction of nucleus for the electron decreases. Okay, if this electron is lying farther from the nucleus, gradually it will have less attraction. Okay, so that's why the atomic radius increases, because the nuclear charge attract the electron, it will squeeze its side. But here in case we have seen that the atomic radius keep on increasing because of the more number of shells. Okay, so what is the trend in the group? When we move from top to bottom, okay, the atomic radius keep on increasing. Okay, atomic radius keep on increasing. Moving forward, what is the trend across the period? Okay, when we move from left to right in a period, we have seen nuclear charge increasing while the number of shell remains the same. That's why the nuclear charge pulls the electron of the shell closer to it. If the nucleus is pulling the electrons, valence electron towards itself, it will gradually have a smaller size as compared to previous one, because when we move from left to right, the nuclear charge keep on increasing but the shell remains the same. Okay, that's why because of this we have seen the atomic radius keep on decreasing as we move from left to right in a period. Okay, I have already given you the example. Okay, and now moving forward, we will learn about the types of atomic radius. Like we have three types of radius. We have covalent radius, we have van der Waals radius, and metallic radius. Okay, one by one we will learn about this. Moving forward, like firstly we have covalent radius. Okay, so this type of radius is always used in the type of species that have covalent bond. Okay, like I have given you an example here. The covalent radius is defined as the half of the distance between the two atoms bonded by single bond in a molecule. Okay, like we have chlorine atom, Cl2 molecule, and half of the distance between the internuclear distance between the chlorine atoms will give us the radius of one chlorine atom. Okay, moving forward, like we have van der Waals radius. So we know that van der Waals is a kind of weak interaction. Like we have two noble gases, like suppose we are taking an example of helium, and we know that they do not combine, they do not overlap, they have very weak interaction, and half of the internuclear distance between this, like we have H2, internuclear distance between the helium 2. Okay, and if we divide it by 2, we will have radius of helium. Okay, now moving forward, so basically van der Waals radius is seen in case of noble gases and those species which have weak interactive forces. Basically we are talking about van der Waals forces. Okay, so here is the definition. Van der Waals radius is defined as the half of the distance between the center of nuclei of the two atoms, okay, held by the van der Waals forces. Lastly we have metallic radius. Okay, like if we are taking an example of iron cluster. Okay, this is the iron, solid iron. We have iron structure, and the atoms of iron arranged in this way. We have seen that there is no overlapping, there is not very weak interaction. They are interacting, but they are not overlapping. So half of the distance between these two atoms will give us the radius of one iron atom. Okay, so basically what is metallic radius, and in which case we will use metallic radius? We will use metallic radius in case of species having the metallic bond. Okay, so metallic radius is the radius of an atom joined by metallic bond. The metallic radius is the half of the total distance between the nuclei of two adjacent atoms in a metallic cluster. Okay, in every case we have to take the average. We have to divide the internuclear distances by 2, or half of the internuclear distance, but difference is only the interaction. Like lastly I have given you a comparison between the three different kinds of radius. Like we have covalent, we have metallic, and we have van der Waals. I have already told you that the van der Waals species, the species that have van der Waals radius, will have very weak interaction. They will not overlap. So the van der Waals radius will be larger as compared to the rest of the two. Like in metallic radius, they are not overlapping, okay, but they are interacting. Their edges are interacting, touching each other. So the metallic radius will be smaller but larger to covalent radius. Okay, lastly we have covalent radius. Here you have seen, it is clearly visible here that they are overlapping. If they are overlapping, it means if we are taking the half of the distance of this species, it will naturally have the very small size as compared to rest of the two, like van der Waals and metallic. So covalent radius will be the smaller radius and van der Waals will be the larger because of the interaction and the overlapping. You have understood very well. So lastly, I would like to conclude the topic by giving a short quick quick revision. Like we have understood what is the atomic radius. We have seen that atomic radius is basically the average half of the internuclear distance between the nuclei of two atoms. We always find out atomic radius in bonded state because the boundary of atom is not fixed. We have seen, so that's why we always find out atomic radius in bonded state. Okay, and I have given you an example. And we have learned about the trends in periodic table. Like if we move from top to bottom, the atomic radius will increase its size. If we move from left to right, the atomic radius will decrease because of the increase of nuclear charges. And in the group, we have increased number of shells. That's why it will have the atomic radius will increase. Okay, moving forward, we have seen the three types of metallic radius. Like we have seen covalent, metallic, and van der Waals radius. We have seen that van der Waals will be the larger radius and the covalent will be a smaller radius because of, in case of van der Waals there is very weak interaction, but in case of covalent we have overlapping. So okay, lastly I have given you I have told you, I explained you this trend, this comparison between the three different radius by a diagram here you can see. Okay, I hope that you have understood well. Thank you for today. Okay, bye.